we need to integrate this with an appropriate substitution. Now there's not really much algebra that we can do with this integrand. We're not allowed to just multiply this cosine through these parentheses because this is raised to the 8th power here. The same is true with the sine. Really the only algebra that we can even start to do would be to start foiling this thing out, start distributing this, but then you'd have to do it 8 times. And nobody wants to do that. So the only option you have for not doing that would be to call 1 minus cosine of x u. Taking a derivative gives us du equals positive sine of x dx. And things are already looking up because we have a du in our integral right here. And this term in the integral right here is just going to be u to the 8th, of course. We just have this kind of straggler cosine of x here. How are we going to get rid of this cosine of x and turn it into a function of u? Well, fortunately, you will notice you can solve this first equation here for cosine of x. I can subtract 1 from both sides. I can divide or multiply through by a -1 to get that cosine of x equals 1 minus u. Well, great. Now we're in a position where we can just substitute everything in. Cosine of x is 1 minus u. 1 minus cosine of x, the quantity to the 8th, is just u to the 8th. And the sine of x dx is our du. Now we've changed our integral into an integral with respect to x with all x variables into an integral with respect to u with all u variables. And that's really good. The only question is, can we integrate it? Well, in its current form, I don't think we can. But now we can use a little bit of algebra. We can distribute the u to the 8th to get this, and now when we integrate, we get 1/9 u to the 9th minus 1/10 u to the 10th, which is a pretty good answer, but we want to get back to the variable that we started this problem with. That's x. So we just substitute 1 minus cosine of x for u. And this answer right here is really good. The only piece of algebra that we might do is we might pull out a 1 minus cosine of x to the 9th power. If we did that, on this first term, we would be left with a 1/9. On the second term, we would be left with a 1/10 1 minus cosine of x. A little bit of trickery to make these numbers look a little bit better. We could actually pull a 1/90th out of this as well. That would leave us with a 10 here and a 9 here. Distributing this -9 would then give us 10 minus 9, which is 1, plus a 9 cosine of x. And I don't know, maybe this form isn't any better than the form that I boxed up here. It's always nice to show you a little bit of algebra. Maybe down the road this will come in handy. For now, we'll just consider this piece to be fun. And we'll call it there. I hope that helps. I'll see y'all in the next video.